All right. So real quick, we're going to cover just general types of load cells. They come in a lot of different form factors, package size. There's different either application or design parameters that are going to be driving these different shapes and sizes, but we'll go through just some of the more popular families here, just as general review. So pancake or low profile, Interface makes more of these style load cells than anyone else in the world. It's certainly what we're known for. S-type, a good versatile sensor, shear beam, rod end, load button, load pins, multi-axis, canister columns, and then some bending beam solutions. So next slide. So here's our low profile. As I mentioned, we make quite a few of these. Capacities ranging from everywhere from 25 pounds above 2 million pounds force. Tension, compression only as dictated on the model on the right, or of course universal, which most of them are. Very versatile, very hardy, rugged sensors. They're good at accepting various application aspects, which you'll better understand when we get through the rest of the presentation today. Offered with an optional base, which we always recommend. And then, of course, we offer many, many different custom variations on this family. So next. S-types come in different shapes and sizes as well, somewhat driven by either dimensional constraints or desired capacity ranges or ceiling parameters. Good versatile also in terms of being able to fit most applications pretty well, relatively compact and relatively efficient from a package standpoint, and also efficient from an economical standpoint usually. So performance is good for most of these models, just not quite as rugged or insensitive as the LP is to various less than ideal application aspects. But we make and sell quite a few of these. And of course, most people think of this as when they think of a load cell, they think of an S-type. Interface founder actually invented the first one and probably should have patented that, what was it, 56 years ago. So, all right, next slide. So shear beam, also common. These are pretty compact, especially from a vertical standpoint when you integrate them into a setup. Relatively stiff, but good high strength and easy to seal. So they lend themselves well for various weighing applications, scale type applications, or if you just need something that is relatively compact and small for a relative load capacity. Bending beam and double bending, these are also very common, real popular for integration into machines, typically lower capacities. And we offer a couple different flavors of these, which we'll show from a flexure standpoint that bring different feature sets depending on the model family there. Canisters columns, these start to become good options as capacity increases. They scale in size against capacity better than, say, maybe an LP from a weight standpoint. They can perform very well if you have good instrumentation to support them. We actually use some of these in some of our calibration frames for reference. Linearity and such may not be quite as good as some other models, but if you can scale that in your instrumentation, it's a non-issue. But again, we can seal them pretty well. That second unit in from the left there, from the right, excuse me, the all blue one that has very high hermetic properties, fully welded construction, Class B connectors, for example. So we can develop these into different ultimate form factors depending on what's required for the application. Rod end, also very common, mostly because they're easy to integrate. When you've got mechanical threads on both ends, it is usually pretty easy to get in line into a load string, and they're also a relatively small diameter. So if you have multiple loads in a test setup and maybe have some radial constraints, these are a good fit. Good in just general push-pull testing. And then we also offer some products such as our WMC there, which actually get quite small and end up being fantastic options if space is a constraint. And we can also offer these with some pretty high hermetic properties, fully welded, for example. Load buttons. Load buttons often get a bit of a bad rap just because performance isn't quite where it is with other sensors. But when you factor in all of the design constraints and compromises there to get to very, very small form factors, it's not to be surprised. Interface, of course, has done some tweaks, which we'll highlight on a couple on one product family to try to bring interface level performance to this type of product. But sometimes these are the only option or the best option. Some of them have mechanical attachments, and some of them require different ways to secure in the test setup. But definitely have their place in the force measuring world, and we've, like I've said, have tried to raise the bar when it comes to the convex BT as well as our LBMU. Load pins are becoming increasingly popular. Very easy to integrate into existing test setups or machines, I should say. Replacing a bolt with a pin is an easy way to get a desired force, whether it be axial or even maybe biaxial, the dual axis setup. They lend themselves to be pretty easy to seal and ruggedize. And we even offer some that are submersible for use in subsea, harsh environments, and of course we have wireless configurations. So if integrated properly, you can get good results from these as long as you take some of the integration and dimensional aspects into consideration. So load pins definitely a good option to consider. Multi-axis also a growing market for us and for our customers. Essentially, you're looking to integrate more axial measurements into a single sensor. Sometimes you can do that through different load strings, different integration locations and test setup, but sometimes it makes more sense just to package it into one sensor. Additionally, they're great for verification on are you actually imparting the loads you think you are to your DOT? So you really get a much better picture of what's happening from a force standpoint. And again, these can come in 2-axis, 3-axis, axial torque, axial bending, axial shear, and we'll dive into some of the flexure differences, for example, from a design standpoint, to accommodate some of the different force measurement needs here.